is Muhammad Aqil bin Amran from Universiti Hussein on Malaysia on the topic on analyzing the PV output using Internet of Things as remote monitoring system. Renewable energy such as solar, which is derived from the natural source, offer alternative sources compared to the fossil fuel. For the number 2, solar energy, a key focus in this project can be defined into the conversion process of sunlight into electricity. And lastly, Internet of Things, which is IoT, enhance the monitoring process for the output of the solar system. For the problem statement, modern PV system depend on the sunlight irradiance to generate electricity. Variation of irradiance level during a day affect the output of the PV system. Conventional PV system monitoring technique require manual data gathering, which is limit the accuracy and the granularity of the data. This project have 3 objectives. Firstly is to design Internet of Things based on the remote PV output monitoring system. Secondly is to develop the hardware and the software component of the intended remote PV output monitoring system. And lastly is to test the PV output monitoring system functionality and dependability in a variability of the environmental circumstances. So for the experimental setup, to carry out this experiment, a setup comprising essential components and procedure is necessary for developing a solar PV monitoring system. The experiment's location is critical for maximizing panel output. Ideally, it should be an area with full solar exposure throughout the day. Thus, the selected site is a parking lot at my university, which is Universiti Hussein on Malaysia. Figures above illustrate the both location and the coordinate. After recording the data for 14 days, this is the table show the calculated value based on the data, the day, the date, the time, and the irradiance value, alongly with the cell temperature. So this is the measured value based on the data also. This is measured value I get from the IoT system and the digital display box in the blue one. So the graph presented, which is the comparison between the calculated and the measured value for both voltage and the current. So as you can see, the comparison is for the calculated and the measured value is below 5%, which is approaching the Malaysian standard for the output of the solar PV system. So the benefit to users, which is number 1 is the user do not exposed to the hazardous solar module installation place. Number 2 is the system will provide the real-time and accurate data for all the parameters. And number 3 is not a complication system, which is more user-friendly for the domestic user. And 5 is cheap and affordable prototype component. So this is my award, which is a silver award during the FYP Industry Award.